Hey, welcome to part 3 of Drivetrains. I'm Craig. Let's talk about some cars. So we last talked about differentials, basically being open differential, which is how we accommodate sending power to two of the rear wheels, and then also accommodate differentiating speeds as we go around corners. Because remember, the inside corner has to go slower than the outside corner, or the outside corner goes faster, however you look at it. Well, I'm basically making the case that we come from the gasoline goes into the engine, right? We make power. The internal combustion engine turns the crankshaft. That goes out to the transmission, either manual or automatic, as we learned last lesson. And that's going to give us different gear ratios so we can keep that internal combustion engine, or ICE, as it's known, the acronym, keep it in its sweet spot, its power band of torque and efficiency. Okay, so we change the gear ratios based on vehicle load. You know, we're going up a hill, downhill, towing, etc. Think about your bicycle. You change gears to accommodate load. After we come out of that transmission, we talked about a drive shaft. Again, that drive shaft has various components we talked about, like a slip joint and U-joints to accommodate height changes in suspension and different angles in that drive line, and also lengths in the drive line through the slip joint. And then it goes to differential. We talked about the open differential again, and the limited slip or locking differential. We haven't really talked about four-wheel drive systems, and that's what this video is about. So in a four-wheel drive system, the power doesn't just go down the rear drive line to the rear wheels, and it goes through a unit called a transfer case. That transfer case is what splits that power to go to the rear of the vehicle and to the front of the vehicle. But there's different types of four-wheel drive systems out there. Okay, basically you have part-time, full-time, and all-wheel drive. It gets more complicated than this, but these are generalized categories for Auto 1, right? Part-time four-wheel drive, and I'm going to elaborate more on these in a minute, but a quick overview of what we're going to talk about. Part-time four-wheel drives, think of you like your old-school military Jeep, right? You get the locking transfer case knob inside the car, locking hubs outside. You put it in four-wheel drive when it's gnarly out, and you feel awesome, right? You get out, you lock it in four-wheel drive, you lock in the hubs, and you get to climb out of whatever dilemma you're in, out in the woods or wherever you're at. And when you get back to the road, you got to put it back into two-wheel drive. Full-time four-wheel drive is kind of like part-time. You still get to go in four-wheel drive high and low, but it's full-time. It's always four-wheel drive. It has a differential setup in its transfer case that allows difference in speed front to rear, which I'll elaborate in a minute. All-wheel drive is kind of like full-time four-wheel drive, but you don't get low range. Okay, it's just think of cars like an all-wheel drive quattro, right? They don't need to lock it in low. They're not crawling out of a rock garden of some sort. So that's all-wheel drive. Again, we'll elaborate this starting with part-time four-wheel drive. So again, think old school American Jeep trucks, etc. You have power coming right here from this engine to the transmission. This is the transfer case right here, where that power is going to split out and either go straight through for two-wheel drive, or when you select it in four-wheel drive, it's going to come out of the transfer case to the side, and then it goes down to the front differential, which works the same as the rear differential, but in the front, hence the name. Okay, so that sends power out here, and that spins this differential, and it spins these axles. Okay, it's not going to spin the wheels yet. We'll talk about that in a little bit, but it spins these axles, and that's what happens when you put it into four-wheel drive. Now, it's going to have high and a low range. That's what makes part-time kind of fancy too, is that the transmission gives you gear reduction. The transfer case can give gear reduction again, either high or low. And then it goes to the differential, which gives gear reduction also. So what this does is it multiplies torque, multiplies torque, multiplies torque. It also slows down the wheels. So it's kind of multiplies torque at a sacrifice of speed. The lower the gear, the slower the speed is, but the more torque you get. Okay. So here's kind of an idea of a transfer case. So as power comes in right here from the transmission, this one could be bolted on to that, or it can be separate transfer case. It could be part of the transmission. Power comes in here, it goes straight through to the rear axle out of this yoke right here. But when you put it again in four-wheel drive, this mechanism side, either chain or gears, can go through to this end of it and then out the front to the front differential, redirecting that power 180 degrees to the front. So here's the reason why you need differential action, and we'll talk about all-wheel drive in a second. So if you're coming around the corner, okay, let me start over. Part-time four-wheel drive is only for dirt use. Okay, if you use this on hard pavement or hard packed dirt, you're going to have binding in the chassis. And the reason why I say that is part-time four-wheel drive doesn't accommodate different wheel speeds front to back. think about the differential. It had to accommodate wheel speeds left to right. As shown in this diagram, if you go around a corner, the right rear of this vehicle is going the slowest, where the left front is going the fastest, because they all take their own paths, which means they all travel different distances. The closer to the center of the circle, the less distance, the less speed. The further out you go, the more distance, the greater the speed. That's why we had differentials, remember, that would accommodate left to right. Well, this front right and the right rear and right front, they still travel different paths, right? So if you look here, right rear goes 19 feet, right front goes 21. There's 2 different feet. So if you had a part-time four-wheel drive on pavement or hard-packed dirt, it's going to have to bind, and eventually the tires will slip, basically, okay? So that's why it's called part-time. You wouldn't leave it in this mode all the time. This is your old school four-wheel drive, again, trucks and Jeeps and whatnot, okay? They can be put into four-wheel drive via different ways. One is manual shifting. So you have a lever inside the cab. You move this linkage and it's going to shift that transfer case internal forks into the correct position to give you four-wheel drive. You can have vacuum shifting. So you push a button inside the cabin. That turns on a solenoid that redirects vacuum to a little servo motor right here. And then that moves those shift forks via vacuum plunger instead of your linkage. Or you can have electronic shift, where you push a button and instead of it operating a vacuum switch, it directly operates the shift motor, and there's a shift position sensor, so it tells the computer what position this transfer case is in, and this is kind of your shift on the fly setup from Ford right here. So as you're cruising on the road 10 miles an hour, you hit the button, this shifts into four-wheel drive. You don't even have to get out of the car. The hubs are automatic and you're good to go. Real fancy system. We'll talk about hubs in a little bit. Right now we're just talking about different types of four-wheel drive systems, particularly part-time. But we have inside that transfer case, you have this chain drive unit, or you have, we go to, hold on, out of range here, gear drive unit, there it is. So you have either chain or gear. So notice this one's gear, kind of like a transmission. If I go back to my chain drive unit, you can see that it links via a chain right here. That comes over to the extension for four-wheel drive. These use a planetary gear set to give us highs and lows. Basically, as you shift it into high or low, just like the automatic transmission, you use this planetary gear set to change the output speed of what's coming out. So it comes in right here from the transmission, goes to this planetary gear set, which is going to change for high or low, and it goes through to the rear or to the front based on if you're in four-wheel drive or not. There's then a breakdown of planetary gear set. If you want more info on that, take a look at that last video, or a couple of videos ago. We talked about the automatic transmission. You have a sun gear, a carrier, and a ring gear. As we hold one and turn one, we're going to get a different gear ratio through those pinion gears. So again, basically we move a sliding sleeve, much like in the manual transmission, and this is going to give us two-wheel drive, four-wheel drive, or four-wheel drive low. Again, this locking sleeve is going to lock part of that planetary gear set. And this is where the high and low comes in. So overview, real quick. I know this gets it gets more complicated than this, which you'll learn more about in our transmission drivetrain class. But overview here is this: transfer cases are going to redirect power from the rear and to the front when you need it, when you shift it into four-wheel drive. It can also, in a part-time four-wheel drive, it can do high and low range. Again, there's going to be gear reduction. So you shift it into low, shift it into four-wheel drive. This transfer case unit is going to send power rear and front, and it's going to change the output to a low range or a high range. High range would be like cruising down on the dirt road. Low range would be trying to crawl out of some type of stuck rock wherever you're kind of gotten into trouble. And then, of course, there's the gear drive units, work similar to a manual transmission. There will be a video on this after this part, so look in there in Canvas. And then the other kind of four-wheel drive, you have all-wheel drive and full-time four-wheel drive. I put these together right now because they work very similarly. Again, the only difference between all-wheel drive and full-time four-wheel drive is that full-time four-wheel drive allows for low range. You can select low range. All-wheel drive does not. But what makes these different than part-time four-wheel drive is this right here, a center differential. So in the transfer case, they have a unit that allows for differentiating speed front to rear. And then the front axle differential and rear axle differential, they allow differentiating speed from left to right. So this vehicle is much more dynamic, much more safe, much more stable in four-wheel drive mode on paved surfaces. You can drive this on a hard surface. Think about your Audi Quattros and whatnot, driving up to Tahoe to go skiing, right? But they're not all-wheel drive, won't have low because they don't need to crawl in rocks. Full-time four-wheel drive will allow you to keep it in four-wheel drive cruising on the road, but it also allows you to do low when needed. Okay. So again, part-time four-wheel drive is what we just talked about before. That's your old school Jeeps, trucks. You wouldn't want to use that cruising down high speeds on a dirt road or anything hard surface because those wheels will slip. That's the way it's designed. It's locking everything, which isn't always the best, but maybe it is. Maybe you want to lock everything, maybe you don't. Just like the differential. It depends on the situation you're in. If you're cruising down in the snow, I would not want a locked rear end. That locked rear end can actually shift the whole axle to the left or to the right based on slope or pitch of the road, crown of the road. And again, maybe I want to lock front to rear axles because I'm trying to crawl out of a rock spot. I don't want them to slip before they move. But if I'm cruising to Tahoe or cruising on down the highway in the snow, I'd want an all-wheel drive or full-time four-wheel drive because then it allows for me to keep it in four-wheel drive on that hard surface as I'm going in and out maybe of snow on the road and pavement back and forth. This system would be superior. So it really depends on what you're driving if you want something locked or not. So that's kind of basically the gist of what this is right there. So I'll skip that. Then you have the transfer case here. What makes this special is this viscous coupling. So as it comes in right here, power comes in, but before it goes out to the rear, it can go through this viscous coupler, and it's just going to basically, it's going to allow for slippage, but the more slippage you get, kind of the more locking you get. So, and then we have locking hubs. So all of this power, we've got power from the engine, the transmission, it goes to the transfer case, it goes out to the rear, the front, either through a part-time locking transfer case, which again is locks front to rear, or all-wheel drive or full-time four-wheel drive, which accommodates differential and speed, mainly through that viscous coupler. So, but that power, as it goes to the front axle housing, it only goes to the axles. It doesn't lock to the wheel hubs yet. Some vehicles have locking hubs that are manual, that you have to go out and turn a dial, and that's going to gauge the axle to the hub. Some are mechanical vacuums, so a vacuum goes down and locks them, or some are electric, some are automatic. But here's the gist of breakaway. As this power comes down the front differential through this axle, it's spinning this axle stub right here, but it's not spinning the hub and the flange where the wheel's connected to. So if you put it in four-wheel drive and you have a manual locking hub and you don't put this in lock mode, you're not in four-wheel drive. You're just spinning this axle. It's not driving the front wheels. You have to lock this hub, which will basically through this unit, it's going to lock or connect this axle right here to the hub splines right there. And that transfers power from here to that hub, and then that drives the wheels. The reason why people like these manual ones is I get to choose when I lock it or when I free spin it, let it just go freewheeling. Why would you want to let it freewheel? Well, if you're cruising on the road in two-wheel drive and you didn't have the ability to unlock this, as the wheel's turning, it would be turning the axle, which is going to turn the differential, which turns the drive line. Now again, you're in two-wheel drive, so it's just spinning free. There's no power going down there, but that's a lot of rotating mass that you're having to waste energy on and burn gas. That reduces your increases friction, reducing your rolling, free spinning basically. So with the locking hub, you can connect it or select free, and that disengages the axle from the hub, so this hub spins free without turning that axle. And when you go put it in four-wheel drive, you get out and you lock in the hub. Or what some people will do is when they're heading up to the mountains or they're going somewhere with four-wheel drive, they go ahead and lock this hub while it's convenient. That way when they get into the thick mud or gunk, then when you shift the transfer case into four-wheel drive, you're ready to go. You don't have to get out and lock the hubs. So it's up to you. Again, it could be automatic, it could be manual. Computer can do it. In an all-wheel drive vehicle, they're just always linked. You don't get to disconnect them, etc. So that basically concludes part 3. Stay tuned for part 4 or click on the next video.